Welcome to another Introscope video. Today we will be going over operators. So an operator is essentially a set of symbols that can perform specific mathematical operations. So I know that many of you guys may be familiar with PEMDAS, which is an acronym for the order of operations. And what this is you may have gone over it in your math class. It's parentheses followed by exponents, and then followed by multiplication or division, and then ending off with addition or subtraction. But in computer programming, it's a little bit different because you have something called modulus, which is sandwiched in between multiplication and division and addition and subtraction. This I will be going over in more depth in a later slide. And so before we do that, we want to go over incrementation and decrementation. So incrementation is essentially adding by 1. You're incrementing a value or adding 1 to that value. An example of this could be, let's say I have an int called I that has a value of 2. If I want to redeclare it and do I equals I plus 1, I can either do it in two ways. I can do I plus plus or plus plus I. They will both result in a value of 2. So incrementation is really useful in loops, which we'll be going over in a later presentation. This applies it's pretty straightforward. Same thing with decrementation. If I have a value of 2 and I want to do I equals I minus 1, I can do I minus minus or minus minus I. And there's also post versus pre incrementation and decrementation. You just saw it right here. So this is post incrementation, this is pre incrementation. If you want to know more about that, we have a guide for more information if you want to see that. Shortcut operators are also very useful, like incrementation and decrementation. So instead of doing I equals I plus 1 when you redeclare a value for I, you can do a shortcut operator. And the sum shortcut operator is plus equals. So an example right here could be, instead of saying I equals I plus 1, you can do I plus equals 1. So replace, just basically combine these two symbols, but place the plus symbol before the equals. This applies to the same thing with difference, which is minus equals, multiply, which is asterisk equals, and then slash equals for division. Another example could be, let's say I have integer called apples, and it has a value of 5, and I have another integer called Granny Smith with a value of 7. Instead of doing apples plus equals Granny Smith, which is 12, I can do instead of doing apples equals apple plus Granny Smith, I can do apple plus equals Granny Smith, which will both result in 12. Let's get straight down to modulus. So I mentioned this in an earlier slide, which is PEMDAS. So modulus is very useful for greatest common denominators and a bunch of more stuff that we'll be going over in the projects later. So just think of it as the numerator of the remainder fraction. If you have a fraction with a remainder, so let's say you have 30 over 7, which equals 4 and 2/7, and you do the modulus, so 30 modulus 7, that will be 2 because the remainder fraction is 2/7, and you want to essentially get the numerator of that remainder fraction, which is 2. So I have 4 problems right here to see if you guys understand modulus, and so feel free to pause the video. I'll give you a few seconds. Alright, so let's go over the answers. So first of all, 28 modulus 5. So the closest value that can be divided by 5 is 25. So the remainder would be 3/5. So this is 5 and 3/5, and then since 3/5 is the remainder fraction, you want to get the numerator. So 28 modulus 5 is 3. 7 modulus 3. So that is 2 and 1/3. So the remainder is 1/3, and therefore the modulus 7 modulus 3 is 1. 117 modulus 9. Now that's actually 0 because 117 is divisible by 9. So when the remainder is 0, the modulus is also 0. And then here's a really important thing that you have to watch out for. So if the value before the modulus or the percent sign is less than the value after the percent sign, that will result in also a value of 0 always. Let's move on to redeclaration. So redeclaration is pretty straightforward. To redeclare data type's value, you just simply omit the data type name. So in this example, int apples equals 5. To redeclare apples, you just get rid of the int, and then apples equals whatever value you want. I got 10 apples. There is an exception to this, however, and these are constant values. So they can be, let's say, a constant int. So the keyword that you want to use is the word final. So that will signal to the compiler that this is constant, so the value cannot be changed. An example of this could be final int quota equals 100. That means that the value of this int called quota will always remain to be a value of 100. And that is it for operators. So if you want more practice with operators, feel free to check out our guide, our practice on our Introscope platform, and we'll see you next time.